Hello auditors, welcome to Open Zeppelin's Recovery Challenge. You can see that over here we got the contract, and in order to solve this particular level, you can just recover or remove the 0.001 ether from the lost contract address. And let's just dive into the code. So firstly, we have this contract recovery, which acts like a factory contract. And so what this does is that you actually generate a simple token having to pass a memory name and initial supply, and then you actually create this particular contract, which they'll pass in the name and initial supply. And moving on, you will see that it's a simple token contract. It's like a simple ERC20 token contract. It's quite similar. So over here we have a simple variable name and mapping address for balances, so basically address to uin. So you can see that the name here is passed in, and the hash mapped is actually added over here. You can see that the creator is been set with balances, so the address of the creator will be set to the balances with the total initial supply. And then moving on, we got this very interesting, I would say, fallback function, or if you will, a receive function that actually just takes in the ether and then multiply by 10 as the tokens, which is quite interesting. But anyways, let's just move on. A simple transfer function, which basically, if you guys remember, like the previous reentrancy challenge where we checked, interact, then perform the effect. So we first check whether there's sufficient amount, and then we remove the amount, and then we perform the effect. And then lastly, we perform this destroy function. So what this does is that you will actually destroy the contract, and then this whole contract, and then send whatever ether to the address stated. Okay, so let's just move on, and it's actually quite simple. There isn't really a need to create a attacker contract because we are using Brownie. It's actually quite simple. So firstly, we have to first understand how the address is actually computed. So among this Ethereum stack exchange, you can see that in order to deterministically compute from the address of its creator and how many transactions the creator has sent, you can RRP encode it and then hash it with KK256. So all this, I'll leave it in the description. This actually, if you want to code via Solidity, if you want to solve it via a Solidity, it's quite simple. Or if you want, you can solve it via Java. Or you can solve it via JavaScript. But then, since we're using Brownie Python, we'll just use the Brownie Python version. So over here, you can just copy paste this into this particular contract. So what this does is that it actually converts the sender address to bytes, then encodes the sender address and nonce using RLP as stated from the requirement, and then we have to encode it and we have to hash it using KK256. Of course, we have to extract the last 20 bytes of the hash to get the contract address, and then we can return it to the interface so that we can actually call the destroy function, which actually sends the total tokens to our particular contract. So it's actually very simple. Oh yeah, for this is just a simple interface. Let me just put here. We just call this interface that interact with this particular contract. So anyways, let's move on. I'll just run this particular script, and I'll pause right here. Okay, you can see that the initial token balance was this amount, and then we have drained all the tokens to 0 from this smart contract and send it to ours. So that's how you actually complete the challenge. But also, this is another way to solve this challenge. Basically, you can actually just take in the instant address and paste it in Etherscan, and this is the smart contract address that is not lost but actually found. Also, we have actually completed the challenge, so if you guys like this tutorial, please hit the like button and subscribe. Thank you for watching and have a nice day.